Hey everyone, welcome back. We're going to continue with 4.2 logarithmic functions and their graphs. Today we're going to focus on graphs of logarithmic functions, and our essential question is, how do I graph logarithmic functions? So I have a lot of this already set up. Go ahead and draw all of this in. It's really going to be helpful if you have graph paper, because every single example is going to involve some graphing. Okay? So pause the video if you need to, but I'm going to go ahead and start with this problem. Example 1 asks us to sketch each of these functions. Over here we have an exponential function, f of x equals 2 to the x power. And then over here we have f of x equals log base 2 of x. We definitely haven't graphed a logarithmic function yet, but we have done exponential functions. And the nice thing about logarithmic functions and exponential functions are that they're actually inverses of each other, which means that over the line y equals x, it's basically going to be kind of like a reflected image, right? So let's go ahead and graph the exponential function because we know how to graph that. I'm going to go ahead and choose a couple of points that will help me. I'll choose -2, -1, 0, 1, 2. These are my kind of like preferred points. It's easier to use these numbers. 2 to the -2 is the same thing as 1/4. 2 to the -1, same thing as 1/2. 2 to the 0, anything to the 0 power is going to be 1. 2 to the 1 is going to be 2. And 2 to the second power will be 4. Okay, so let's go ahead and graph the exponential function first. So let's go -2, 1/4, really close to 0, -1, 1/2, 0, 1, 1, 2, and 2, 1, 2, 3, 4. So here is my exponential function. We already know from previous sections that this thing is going to glide right along the x-axis because it has a horizontal asymptote right there, and it's just going to keep on going up, up forever. Okay, so that's our exponential function f of x equals 2x, or 2 to the x. Okay, now in order to do the logarithmic function with base 2, all I actually have to do is switch my x and y values. Okay, so if I have 2 to the x and then log base 2 of x, it's just the reverse or inverse of each other. So if this was 3 to the x, log base 3 of x would be the inverse. Okay, so I'm going to go ahead and make the table. And essentially what you're just going to do is switch the values around. So at x equals 1/4, you're going to get f of x -2. At 1/2, you're going to get -1. At 1, you're going to get 0. 2, you're going to get 1. And at 4, you're going to get 2. So like I said, I switched my x and y values because that's what's happening when we have functions that are inverses of each other. So they're reflected over this y equals x line. Okay, so let's go ahead and graph that. 1/4. Right around here, -2. Half, we'll get -1. 1, I get 0. 2, I get 1. And 4, 1, 2, 3, 4, I get 2. Okay, so this one's going to go all the way down. Vertical asymptote now at y equals 0, or x equals 0 actually. And there is my logarithmic function, log base 2 of x. Okay, so that's one way to do it. You could graph the exponential and then just graph the inverse of it in order to graph the logarithmic. I'm going to show you a couple other ways though that kind of require less work. That way you don't have to graph 2 different graphs. So let's go ahead and jump to example 2. Again, there's going to be a lot to set up, so pause the video as needed. We're going to sketch the function. F of x equals log base 3 of x. So I could graph the exponential function 3 to the x and then graph the inverse of it, or you guys can also do an XY table. In this case, I'll use x and f of x. Now here's going to be the interesting thing about the XY table for this one. It's actually more difficult to just choose random x values, because if I were to plug in, let's say, 2 into this equation, so log base 3 of 2, I would actually have to figure out what log base 3 of 2 is equal to. In other words, what the exponent is for 3 to become 2. That's a bit too confusing, so I think I'd actually rather work in reverse. So rather than doing all that, I'm going to go ahead and set f of x equal to something. And the numbers I'm going to choose are actually going to be the same ones that I chose earlier for my x's. So I'm going to choose -2, -1, 0, 1, and 2. Let's go ahead and see how we can do that. I'm going to set this up first. Okay, so the first one I want to do is f of x equals -2. So f of x, which is log base 3 of x, equals -2. Okay, so just reviewing from Friday, this is the base, this is essentially the exponent, and this is the answer after you put these two together. So rewriting this into exponential form, I have 3 to the -2 equals x. So the x value that I'm going to get over here will be 3 to the -2, otherwise simplified as 1/9. Okay? So at x equals 1/9, my y value is -2. I'm going to keep doing that for the rest of them, so I have f of x equals log base 3 of x equals -1. So 3 to the -1 is equal to x. X is equal to 1/3. I'll go ahead and do, I guess, the rest of them. F of x equals log base 3 of x equals 0. 3 to the 0 is equal to x, which means x is equal to 1. Let's do the rest real quickly. Log 3x equals 1. Log 3x equals 2. 3 to the first is x, so x is 3. And then 3 to the second equals x, so x equals 9. Alright, so we are going to need quite a bit of space on here, but mostly in the positive region. Let's go ahead and look at that. Okay, so let's go ahead and graph this guy. At 1/9, so really close to 0, we are down at -2, so let's put a point there. 1/3, even closer, actually not even closer, a little bit closer, is -1. At 1, I have 0. 3, I have 1. And then all the way at 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, right over here, I'm at 2. So my logarithmic function will look something like that. Okay? I want to go ahead and jot down some information for this domain. Obviously, all of our x values have to be greater than 0. Okay? All of our range, actually it's going to be all real numbers, because it goes all the way down and goes all the way up. And then notice you actually have a vertical asymptote right here at x equals 0. In terms of a horizontal asymptote, we don't have any. And then for our x-intercept, actually, it's going to be at 0, 1, or 1, 0, sorry. And that was actually the same as the x-intercept right up here. So essentially, if we don't add or subtract anything to these guys, that's where our x-intercept will always be. And in terms of y-intercepts, none, because we have a vertical asymptote there. Okay? There's example 2, quite a bit of work too, but that way we don't have to graph 2 different functions. and we got this guy. Okay. Final part, we're going to go ahead and go to example 3. Need a paper for me. And the final part is basically transformations of these functions. And I'm going to give kind of like a cheat sheet for it. So I'm just going to split that up. Example 3. I want us to sketch f of x equals log base 3 of x plus 1 and f of x equals negative 4 plus log 3 of x. Okay? So I'm going to use the same base of 3 just so that I can go off of the previous function. Let me go ahead and sketch that in really quickly. So back over here, here, and here. And then I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. Okay, so all I did was graph the original parent function of log base 3 of x. These two functions that I have up here are actually just transformations of this original one. And what they tell us to do is basically move left, right, up, or down. This one, because I'm adding a 1, I'm actually going to be shifting all of my coordinates to the left. So shift left 1 unit. If I really wanted to prove to myself that that was true, I could actually make another XY table using that, and it would look something like this. Let's go ahead and set it up down here. So x, f of x, again I want to work backwards, so negative 2. So what happens is that I have log 3 of x plus 1 equals negative 2. 3 to the negative 2 is equal to x plus 1. So I get 1/9 equals x plus 1, and I have to subtract that awful number over there, and I get negative 8/9 equals x. Okay? That does help us out, at least to organize our information. But if you really don't want to do that, the best way to do it really is just to shift everything over to the left by 1 unit. So if you see something being added to x, shift to the left. So 1, 1, 1, 1, and 1. Okay, so that does change our domain a bit. Range stays the same. Horizontal asymptote is still non-existent, and vertical asymptote also changes as well. With this one, because I'm subtracting 4 from the overall total, that means my y values will change, and this graph is going to go down by 4 units. So if I were to shift this one, this would be shift down 4 units. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And it's going to go super low. 1, 2, 3, 4. Somewhere down here. This would be log 3x negative 4 plus. Okay, so really it's just a transformation of our original. So if you're adding inside the x, let's just call it c, left, subtracting, right, plus log, down, and running out of room, time, up. All right, out of time. Let's go ahead and call it there. Have a good day, you guys.